Hello students, in this video we will solve some of the MCQs based on chemical thermodynamics. See the first question, which of the following statement is correct? The presence of reacting species in a covered beaker. Now as the word here is covered, means this is an example of closed system, but they say it is an example of open system. So the first option is wrong. There is an exchange of energy as well as matter between the system. If there is an exchange, means this is an example of open system, but they say this is a closed system. So this is also wrong. The presence of reactant in a closed system, as the system is closed, this can be an example of closed system. They also say this is an example of closed system. So the answer here is third option. Let us check the fourth option also. The presence of reactant in a thermos flask. Whenever you get a word thermos flask, means this is an example of isolated or insulated system, but they say that it is an example of closed system. So the fourth option is also wrong. So for this question, the correct option is third option. In thermodynamics, a process is called reversible when a reversible process is one in which there is a continuous equilibrium between system and surrounding at every stage of the reaction. So if you go through the options, here the answer is third option. Let's see the next question. Which of the following is the largest unit? Now here they have compared the units on the basis of magnitude. So students, you know that 1 cal is equal to 4.18 J, 1 J is equal to 10 raised to 7 ergs, and 1 cal is equal to 2.6 into 10 raised to 19 electron volt. If I compare the magnitude, cal is the largest unit. So the answer here is first option. See the next question. An intensive property is that property which depends upon. Students, intensive property is one that does not depend upon the amount or the extent of the substance, but the property whose value changes with the change in the type or the nature of the substance. They are intensive properties, and therefore the answer here is first option, the nature of the substance. Thermodynamic equilibrium involves, actually thermodynamic equilibrium is based on pressure, volume, temperature and chemical composition of the system. Now here, when we consider pressure and volume, we collectively use a word that is mechanical, and for thermodynamic equilibrium, we consider all the three types, that is chemical equilibrium, thermal equilibrium, and this is actually PV equilibrium, that is called mechanical equilibrium. So the answer here is all the three. Which of the following has no change in the internal energy? When it is isobaric, means the pressure remains constant. So here delta P is 0. Here delta V is 0. For isothermal, internal energy as well as temperature, there is no change. So here delta T and delta U, they remain constant. For adiabatic, Q is constant. So according to the question, the internal energy, there is no change, is for isothermal process. It is general principle that less is the energy of the system, more will be its stability. So the answer here is second option. Mass and energy are conserved is demonstrated by, actually this is demonstrated by the modified first law of thermodynamics. So answer here is fourth option. Warming ammonium chloride and sodium chloride in a test tube is an example of, whenever we heat something in a test tube, it is a simple example of open system. So answer here is third option. During the adiabatic process, now students, adiabatic process is one which is insulated or isolated, and the heat is neither allowed to enter or leave the system at any stage of the reaction, means it is perfectly insulated, and therefore the answer here is third option, that is perfect heat insulation. If W is the amount of work done by the system and Q is the amount of heat supplied to the system, so some work is done, some heat is allowed, and there is no matter change. And if there is no matter change, means this is a example of closed system. So answer here is second option. Which of the following is an intensive property? So temperature is an intensive property, viscosity is an intensive property, surface tension is also an intensive property. So answer is all of these. Which of the given properties depends on the path along which the change or the process is carried out? Now students, always remember there are only two path functions, that is work and heat. So if I see this, answer is second and third. So let us mark the options. Here the answer is third option, both second and third. Predict the total number of intensive properties here. Let us mark the properties one by one. Free energy is an extensive property. Density is an intensive property. Viscosity is an intensive property. Specific heat is an intensive property. Molar heat capacity is an extensive property. Enthalpy is an extensive property. Specific gravity is an intensive property. Molarity is an intensive property and pH is an intensive property. If you count the number of intensive properties, it comes out to 6. So the answer here is fourth option. Out of boiling point, entropy, pH and EMF of the cell, the intensive properties are. So let us mark them again. Boiling point is an intensive property. Entropy is an extensive property. pH is an intensive property and EMF of the cell is also an intensive property. So the answer here is first, third and fourth. So answer is third option. Let's see the next question. The temperature of the system decreases. You know students, temperature directly depends upon the kinetic energy. And kinetic energy is directly proportional to the number of collisions that takes place of the gas system. Now if you are decreasing the temperature, then the process where we can see that the temperature decreases when the gas expands. So this answer here will be adiabatic expansion of the gas. So the answer here is third option, that is decrease, and therefore we say that when the temperature decreases in adiabatic expansion. So the answer here is fourth option, adiabatic expansion. See the next one. In an isochoric process, the increase in internal energy. For this, let us solve the question. Now you know students, for an isochoric process, delta V is equal to 0. Now let us see the first law equation. Delta U is equal to Q plus W. Now if I want to see delta V, what I have to do is, I will reframe this is equal to Q P delta V. Now this is 0 and therefore there won't be any work. So delta U is equal to Q. So this is the expression what we got. Now whatever the increase in the internal energy will be there, this is only because of the heat which is supplied, and therefore the answer here will be that the work which will be done is only because of the heat absorbed. So the answer here is first option. The increase in the internal energy will be equal to the heat absorbed. Let's see the next question. In isothermal process, if heat is released from an ideal gas, then equation will be same student. So if I say delta U is equal to Q plus P delta V, you usually take the expansion of the gas. So I'll make this minus. In isothermal process, this is 0. So Q is equal to P delta V, or you can call it as W. So whatever the heat is absorbed is utilized for the positive work, and if it is released, then it will be negative work. So here the gas will do negative work. So the answer here is third option. Let's see this question. 5 moles of a gas they are put. A graph is given. Now students, always remember, when the graph is given, you see here volume and temperature. We usually consider the graph for P, V and T conditions. Here you are seeing volume and temperature. So the third factor, that is pressure, will remain constant in this particular process. So let us see the first one. The process is from A to B. If I see A to B, the temperature has changed, but the volume has remained same, because the volume at which the point A and point B, both the values, they are same. When the volume is same, we call it isochoric process. So here I can go for first or fourth option. See the next one. The gas is changing now the path from B to C. If I see B to C, the temperature has decreased as well as the volume has changed. The third factor, that is pressure, which is not here, means the pressure is remaining constant, and for pressure it is isobaric process. See the third one, from C to A. If I see from C to A, volume has changed, but the temperature is constant. And the temperature is constant, it is isothermal. So the answer here is first option. I hope you have understood the concepts related to those MCQs. If you want few more MCQs to be solved, please do write in the comment. Do like this video if you have understood the concept, and please subscribe to my channel. Thank you, students.